So today's session, we're going to start with the goals that you have for your in-memory database. And that's going to allow us to choose an architecture in which to run Ignite. We'll then have a brief overview of some of the Ignite facilities, such that we can make the right decisions around things like, click's not working, there we go, around storage, ingest, consumption, events, and egress. All right. So then we're going to move into designing, and the idea with designing is accelerated pattern-based development. We don't want to start everything from scratch, so how can we get good developments in your hands that can help you? And then development, once you've designed it, let's develop it in the different diverse environments that people have. And then in order to deliver an in-memory database, we have to deploy it. So there's various deployment options, and you've just gone over some of our monitoring features. So that's great, with the intent of developing an in-memory database to meet the needs of your modern digital business platform. That's kind of what I'm hoping to get for you, is Ignite as a modern digital business platform. Okay, and after developing or delving into each of these areas, I'm going to walk through 3 approaches. Actually, you'll see through the presentation a lot of the steps, but 3 specific labs using SQL DDL to build your solution, going with Ignite examples as a starting point, and then using the web console and control center to build your config and use the database import wizard. So that's kind of the agenda for today. So it's jam-packed, and I will be sharing this, and there's lots of notes in here, so you don't need to take every exact note down. We can share this for you later. Okay, so let's start off with the goals for using in-memory database and thinking about the frameworks and architectures in which an IMDB can use in service of those goals. So what are your goals? And these are going to be different for each person. You know, you may be wanting to create a digital integration hub to span multiple applications and databases and bring them together in a unified way. You might be processing messages in real time and streaming those events in for analyses. You might want to accelerate and scale out some existing applications that aren't maybe scaling the way you need to. You want to build from scratch a modern, real-time, web-based, web-scale application. That's where an in-memory database really can help you with that better than any traditional database. And then very often you might have existing antiquated systems that are maybe at their maximum and they can't take on new load. And so you might want to offload those antiquated systems, either for new applications or even to make your existing applications go fast. You might want to update some existing applications and, again, build modern new apps. And there might be something else. You know, that's just a broad selection of what is possible with an in-memory database. Okay, so there are many goals, but let's think more broadly about the modern digital businesses. Gartner sees that a typical business or businesses have 4 broad organizations and associated technical platforms for those. So customers have their customer experience platform, web-based interaction with their customers. Partners have a partner ecosystem for exchanging messages and data and so forth. Employees have their internal information systems platform. And then things, quote unquote, as an organization for all of their IoT type of, their IoT platform. And then in the core, in the middle, or the nexus of those 4 platforms is where your data and analytics platform really resides. And it's this central data and analytics platform that's the engine driving the businesses in the digital era. And what Gartner's paper on introducing the digital integration or digital business technology framework, what they didn't talk about there was the data management practices and how integration would happen in these scenarios with these multiple platforms. So these are 2 areas, integration and data management, where architecture really comes into place. So they're talking here about frameworks. We're going to talk about architectures. Okay. I guess we already talked about those things. Okay, So when looking to implement the business or organizational specific technology platforms as listed above, you know, the Digital Integration Hub, or DIH, is an architecture that works well for 3 or 4 of those organizations. And when we look at the DIH, it has these core components: storage for persisting your data, compute for computing, or facilities for computing logic and services to deliver to consumers, and then integration facilities to ingest and egress data from external sources and targets. So with all this, the Ignite DIH supports a multi-model, multi-mode, and multi-consumption patterns to your many consumers. Now, when depicting it like this, you get the sort of the API-centric approach to things, but we're going to focus on the integration piece of this, which is the bottom 2 layers. So just taking those bottom 2 layers, we're going to create a horizontal pattern or architecture for this, and I'm calling this the horizontal digital integration hub. Okay, this is a more traditional data landscape where source systems are on the left, generating data and flowing to subscribing components, and ultimately out to target systems on the right that may need to take advantage of the data and services that we're going to build with our in-memory database and our DIH. So in the center, we still have the storage. Let me see if I highlight that. We still have the storage and compute, and above it, the consumers through various APIs. Just make sure I have the questions highlighted here so I don't miss anything. Please feel free to stop me, or if something doesn't make sense, by all means, continue. Interrupt. Okay, so we talked about focusing on refactoring 2 levels: source systems, inbound integration, outbound integration. Okay, now the digital integration hub is not the only architecture that could be used to support technical frameworks that Gartner laid out between customers and your analytics system, or your IoT devices, etc. A traditional enterprise data warehouse with operational data stores and dimensional data marts, maybe another architecture that you could use. That's a more legacy approach. And there are other architectures making the rounds today, like Smart Data Hub or Smart Operational Hub. Those are more aligned or akin to your digital integration hub. But one other alternative architecture that's very appropriate is the enterprise event stream processor. And all right, so that showed up automatically. The ESP, or event stream processor, fits better with those technical platforms that have more fully moved on to a fully real-time, message-oriented, event-driven paradigm seen in this diagram here. Again, however, it's data sources on the left, streaming data in to the integration hub in the middle. So it's very consistent and compatible with the DIH, just a more focus on streaming and messaging facilities. And this is a good fit, as I said, for your IoT or systems that are more event and stream based. Okay, so I've shown 2 architectures into which an Ignite in-memory database can fit. However, I want to contextualize the Ignite IMDB based on the patterns that you can use it. So architecture versus patterns. Let me explain that a little bit here. So there's a few system patterns that Ignite delivers, and so I'm just going to reorient ourselves here. So there's the data grid pattern, in-memory data grid versus in-memory database. So I'm going to talk about those 2 just because I think it's really important to keep these things too clear. When you get into implementation, it makes a difference. All right, so the basic caching pattern, or IMDB, or IMDG, shown here, I call that a vertical data grid pattern because you have your external data in a third-party database like an Oracle or SQL Server system, and you've got consumers on the top, and we've slid, that's the technical term we use here, slid the in-memory data grid in between to provide accelerated support and potentially new APIs to your consumers at the top. But that's a caching strategy. The in-memory data cache is not responsible for the long-term persistence of the data. If the cache goes down, you bring it back up, you recache everything, you go on your way. But you have to have a source of the data that's persistent and has backups and all those kinds of good things. That's when you get into the in-memory database pattern, or IMDB. Okay, so this slide shows that, and I call this a horizontal pattern because, again, we have the data on the left moving into the center, and the center is a reliable database, right? It needs to ensure the resilience of that order that you just received over a messaging system, because once I've consumed it off the messaging queue, it's gone. Once someone has sent me a CSV file for my latest product database, they don't necessarily guarantee that they're going to keep the product file around for you to FTP it every, for the next 2 months. No, you're responsible. You are a database. So that's the IMDB pattern. It's horizontal. It moves data in and into the cluster. The cluster is using persistence on disk for reliability and consumers above it. Hope that makes sense. Now, these aren't 100% mutually exclusive. There could be some databases that you want to continue to leverage. And this is where you get into a hybrid approach where you have some data that's moving in, that data that you can't rely on being around, external systems or systems that you don't want to go back to. Those are going to be stored with reliable disk-based Ignite persistence. But you're also going to have some databases that might still exist that you might want to synchronize with and use more of a data grid pattern. So a combination of data grid and database. You just need to know, where are your lines going? Some data is coming in, some data is being synchronized with an existing database. So those are the two approaches, data grid with database, to combine together into a hybrid approach. But you should keep in mind, are you caching something else that has to exist and be there that then I'm synchronizing? Or am I getting data feeds and I'm going to take responsibility? I want to keep it for 6 months. I want to keep it for a year. I want to keep those kinds of things. That's a database. Okay, we're going to focus on this training session on the database side of the house. Any questions at this point? Please, feel free. Because at this point, we're going to jump in, unless there's any questions, we're going to jump into some of the facilities that the IMDB has. Okay, so Ignite and the extended GridGain platform is clustered, memory-centric data storage and computing platform. The Ignite core, as you see here in red, provides in-memory storage and computing, along with a rich set of consumptions APIs on the top. SQL, key value, compute, services, ACID level transactionality, stream ingestion, event-based processing, message-oriented movement, and semantics. And then the blue stuff, or gray as it shows up on my screen, those are the enterprise features for things like data center replication, security, auditing, monitoring, management, rolling upgrades, and stuff like that. Okay. On the storage side, let's focus just on that. Again, here you've got both SQL and NoSQL semantics, or APIs. So it's bilingual. Okay, you can do both. And you have full ACID level transactionality available to you. Okay, now this can be delivered to you in memory only. That's the data grid we talked about. Memory with external third-party persistence. That's the in-memory data grid as well, but tied to some kind of relational or NoSQL database. Usually that's something we call a cache store, or third-party cache store. And then the third option is memory, but using Ignite native persistence for that resilience, for that persistence over time, durability, and for expansion beyond what your memory has available to you. Okay, moving on, I'll just highlight here the native persistence side of the house. Again, you've got memory, and for things that exceed your memory, you have disk available for overflow as well. There is a transaction log, or what we call the write-ahead log. And when you are putting or removing, that uses memory and the wall and transitions, make sure everything is durably stored or persisted to the Ignite disk. When you do the get in blue, you're going to pull that into, pull it out of memory or disk, and load will take a data source and load it in. Okay, so this is memory centric. It's disk back for overflow, It's multi-region tiered storage, so you can have memory, disk, multiple versions of disk, multiple storage regions, etc. It's transactional, and there's a full API across all of these storage regions. Key value, SQL, SQL query, etc. So even if you overflow memory when you do SQL, the query will run across to the disk. That's different than the in-memory data grid API, in that if it's not in memory, it won't read through or query through to disk or third-party persistence. You can read through if you know the ID of the customer, but if you're doing search for customers where their foot size is greater than 10, the query will not query through. That's the difference. And in this case, the cache store is only used for loading. It's not used for synchronization between the Ignite environment and third-party persistence store. It's just for loading data. Again, it's horizontal. It's pulling from left to right. All right, so I probably should have done this one before the Ignite, but so the third-party persistence, it's implemented via a cache store. That's what you see here. And they come delivered out of the box. Popular ones come delivered out of the box with SQL and NoSQL databases. It provides read-through for missing entries and write-through for synchronization. So your cache and your database is in sync with anything you do with the cache. Again, it's got full ACID level transactionality, two-phase commit, synchronization to your oracles and SQL servers of the world. Right, and again, here in the lines, the put and remove, which are writable things, those will go through the write-through interface of the cache store. And then when doing get, you will go to the cache, and if it's not there, it will read through to the database to find that customer ID that you were looking for and don't have in memory. And then when you click load signals to the cache or the cluster, hey, reach out to the data source and pull it in. Okay, so that's what those lines are supposed to imply. Okay, so moving from storage to integration facilities, Ignite has a number of tools, APIs, and services that support or facilitate integration. For example, you can use Ignite's provided SQL line tool or any JDBC or ODBC tool to ingest data. You can write an app using the key value or SQL APIs to add or ingest data into the cluster. You can use Spark if you wanted to store a data frame into a cluster. All of these things are possible. For this scenario, or for this training, we're only going to focus on the Ignite data streamer and its API, because it's the fastest. It supports buffered multi-threaded writes. It's topology aware, so if you've got a 100-node cluster, it knows where it should be moving the data, so it minimizes the inter-node network I/O and the memory impact of all the data being loaded. It's got extensible receiver logic, so when you send it to a particular node 35 of your 100 nodes, it can do stuff there specific to when it arrives on your cluster. And it has at least once loading guarantee, so it will at least load it once. Right? You will not miss loading the values. They will all get there at least once. Now, it does not support transactional semantics directly. There are implicit transactions, and you can define user explicit transactionality. However, keep in mind, you don't have ordering guarantees. So what happens on node 34 might be after what happens on node 25, right? You can't guarantee the order in which those things arrive, but you can set up implicit or user-based transactions on the individual record level. Okay, and this is, as I said before, the fastest loading mechanism and supports both bulk and incremental feeds into your cluster, into the IMDB or IMDG. Okay, so moving from storage and integration to compute,
hey, Glenn,
we're going to focus on event handling interface and the interfaces that can call the compute logic on real-time events. And there are three primary event-triggered facilities there. Those are the cache entry processor. This is processing associated to putting or updating an entry. There are cache interceptors, And this is a more feature-rich API that enables before and after callbacks for the get, put, and remove invocations. And the interceptor, as its name implies, has visibility to pre and post changes. And so you can adjust and prevent actions. You can also do differential comparisons for delta processing as well. Just keep in mind that the cache interceptor, you are intercepting something that is part of a transaction. So you gotta be careful. With great power comes great responsibility. So be careful with the cache interceptor. If all you care about is post transaction, the query, the cache entry, the continuous queries is a better approach. And we're going to focus on the continuous query here. That's what is used mostly for event-based processing. Again, avoiding the ETL or the loading process like the cache interceptor. So here, the continuous queries has 4 main components. It's the initial query that gets initially invoked to set up what data are you interested in. There's the remote filter that allows you to provide extra predicates on the receiver side or the remote side to say, hey, you asked for all sales in this city, but you know what? Have these expired yet? No, then I don't want to look at them. So that's the remote filter can exclude some things in addition to your query. And then the local listener is the logic you want to apply when you receive events from the cluster. And then there is a remote transformer. So if you want to enrich your events, you can do that as well. Okay, so if we look at what things an event triggering facility can call, these are a good list for us to go over. So these are the things you can call in your event-based processing. You can call distributed closures, and here you're going to broadcast out to the cluster and load balance these closure executions across the cluster nodes. Compute tasks can execute map reduce and fork join tasks in memory and also are pre-deployed as RESTful services. You've got the affinity call and run to co-locate the computation with the data. You've got machine learning and distributed deep learning, classification, regression, clustering algorithms that can be applied. The important thing here, this is a big thing, we're not going to talk about it much today, but the big thing about this is that our ML and DL algorithms are partition aware. So it takes the compute and delivers it to the cluster, to the data where it resides, not bringing all the data back from a fast database, but clogging the network with bringing all the data back and forth as your algorithm executes multiple steps. And then business rules. These are any kind of rules or logic you want to apply. For instance, rules can be deployed as a distributed closure and executed when events occur. So you can have business users and business rules that get picked up and automatically process logic based on the events firing in Ignite. Okay, so we've talked about the architecture from the goals that you've got. There we focused on the digital integration hub. We talked about the 4 core components of the IMDB, where storage, ingest integration, consumption, events, and egress for sending stuff out. Let's focus now on the sort of core parts of designing an in-memory database, assuming now we know what we're trying to do. And again, the focus here is on accelerating patterned development here. Okay, so these are good patterns to meet your needs now and into the future. Okay, so in thinking about designing an Ignite IMDB solution, we should think about the following elements. Okay, Ignite IMDB is like a database, so it's not unlike a relational database. And so that's a good place to start to think about how I'm going to design my database. However, in addition to a regular database, RDBMS, etc., Ignite as a cluster extends beyond the traditional central database pattern, and it adds additional things you need to think about, like partitioning, replication, affinity of entries, and co-locating. Now, it's also NoSQL semantics, so look at your key value storage and access semantics and see if that's something you also want to use and take advantage of while you're also designing your relational view of the world. We are bilingual here. You can support both. Let's think about how we do both. We talked about all the compute stuff we can do. We've got massive parallel capability. We've got co-located compute. So think about what would you want to do in your services? How would you use the power of distributed processing and distributed data together to give you faster service implementation? Instead of having a monolithic service implementation in a separate layer, include the service with your data. Events. This is, Ignite is activated with a rich pre and post transaction event facilities. How would we want our database to support events? So it's not just triggers like you would have in something like a SQL Server environment, but it's a full interceptor, filter, streaming, all this processing we have capability for. So let's think about how we do that. And then ingest. We've got performance optimized APIs and facilities. How will ingest affect how we design our IMDB? Okay, so in thinking about designing an in-memory database, in addition to thinking all those aspects of the solution, these are some of the questions I would ask of your solution. Okay, data model. What's the optimal data model? We want to match up the consumption needs, the consumers, the tools, the applications that are going to be using the database in the database with the structure and the patterns of our ingested data. And we want to match those two things together. Won't necessarily always be just what the user wants. It might also be what the data looks like on the way in. We've got to match those two things together. Tools. What user tools are going to be involved here? Is it going to be just developers building applications using NoSQL, or is it going to be end users who might want to run, ad hoc queries in something like a Tableau or a Click? Right? These different tools apply, make you think about different ways of designing your solution. Okay, what applications does the database have to support, and what level of service will they need? Do you need to have sub-second response for things? Do you want sub-second for some? Can you live with longer for others? So those kinds of questions go into your database design, just like you would think about, setting up what indexes do you want? What APIs will your different user groups need? So developers might want key value, your end users might want SQL, your administrators might want to look at things through SQL, etc. So think about the APIs that you want there. And what's the pattern of arrival that you're going to have in your solution? Are you going to have streaming data? Are you going to have files sent to you on some scheduled basis? Are you going to pull it? Are they going to be pushed to you? These different ingest patterns and the shape of the data as they arrive is important to your solution. And then what services, will you deliver from the data that you've got in your database here? And then what data would others make use of? Downstream systems, systems that might say, hey, we've done a whole bunch of streaming analytics and we found out that the shopping cart could really take advantage of buying avocados from the Instacart example. And hey, let's suggest that. Well, I need to stream that out to my web system. So that's a target system that needs some of that event data. So what are those, how do you egress the data, and what kind of events do you want to push out to those target systems? Okay, so we've talked about things to think about. We've talked about questions, and then what are our approaches that we have for building an IMDB solution? Okay, so we're going to talk about 3 approaches here. We've got SQL DDL, right? This is a data first standards-based approach that if you're designing for the last 20 years, this is probably the approach that you're familiar with. And familiarity is great because that can give you a more productive development experience. That's fine. However, there might be times when you want to look at the extensive library that we have for you and look at, how has this solution been solved, by Ignite and the Apache Software Foundation team of developers with Ignite. So there's an extensive library that you can pick from that will show you best pattern approaches for building out your solutions. And then the web console, and soon the control center, will have are tools that can give you a patterned package, Java Maven project, that will allow you to import a database from an existing source and give you a project based on what that looks like. And what we as Ignite database that matches that, what would we look like if we matched that database? Or straight from scratch, you can build a cluster by walking through the panels that show you the capabilities that Ignite has, exposing it for you and delivering it for you. So those are 3 key approaches to deliver this stuff, to build a solution, an in-memory database solution. Okay, so here's where I was really referring to, don't write any of these things down. These are some resources that will help you in designing an IMDB solution. So I'll just highlight a couple of them. You know, there's a whole section on our page for Ignite data modeling. There's a discussion that I think is important around the Ignite in-memory architecture that applies to your solution as well. If you're going down the SQL approach, getting started, the SQL reference, and working with SQL, these are all pages that really are good to get a good handle on before you delve into these things. The memory architecture, I think, is important. Ignite persistence, because we are a database, thinking about and knowing what the capabilities of Ignite persistence is very important. And if you're getting into using an in-memory database and you want to make sure of transactionality is there, stable, consistent, atomic transactions, then you want to look at that page there. Okay, so let's focus on the SQL compatible database design approach, the first of 3 approaches we're going to go over in this session. Okay, so the approach for this is really a 3-step approach, fairly traditional, so this shouldn't come as a shock to anyone who's done this for the last few years. You're going to do your requirements analysis. You're going to map out what how do you do development. A little bit of that is maybe you take an Ignite development course, training course, and what are your system strategy approaches? How does Ignite fit into that? The big thing is, for me, is what's the scope of what we're building here for your database? Are we talking about the HR, schema? Are we looking at that business area? Are we looking at finance? Are we looking at, ordering? What is the scope of our planned database? Then that moves you on to the database design phase. And you're going to start with a model-based approach, looking at what your requirements are. And you're going to do that first before worrying about the physical implementation. But then you do after you've got your logical model, look at incorporating some of the physical design characteristics to implement that logical model. And here you can use the SQL DDL directly into Ignite via the SQL API. Then for implementation, you're going to take that physical model, you're going to then load data into it, you're going to extract data, translate, and load the source data. If you are using the IMDG and you have a cache store, you just have to load, because in an IMDG, you are synchronized with the database. So there isn't any translation, and extraction is really the wrong term. Extraction and loading is the wrong term. It's synchronizing the data, and the cache store will do that for you. You're going to test and confirm the validity of your loaded data. You're going to start building your applications. You're going to start doing some of your reports or your dashboards. And then most likely, you're going to do this. You're going to iterate back, figure out, have I got all the requirements in there? Have I met the needs of what this planned database system is? And, iterate through this process as you go. Oh, I did see, so a question did come up. Let me just make sure I address this. Okay, so any performance advantage for key value API over the SQL JDBC Ignite streamer? Okay, so yes, so both support streaming. So let me just put it that way. So the SQL API does have an operational command to set streaming on. So you do get streaming through SQL. And then the alternative is the key value API for data streamer, where you basically put a record into the data stream, into the streamer, and let it decide how much it's going to cache, how much it's going to send, and so forth. So you do get both, but I have found that streaming with key value seems to be faster. Now the problem with, and why I say seem, is the SQL approach generally is on different machines, and so you're going by necessity over the network to the node that you're connecting to. With the latest version, whereas in the API with the data streamer, you can run that local to your nodes. Now, having said that, two things. One is you're going to be running your streamer somewhere, and if you have a multi-node cluster, it's obviously going to have to send it at some point. So it's not exactly what I said before. It's going to have to send it over the network anyways. And on the SQL side, with the more recent versions of the JDBC driver, there is partition awareness, so it should have taken away some of the advantage that the API has. I haven't rerun my tests since then, but if you want to do SQL at the fastest possible, make sure you take advantage of the partition awareness. That's a special option. That's not the default on your JDBC driver, on the most recent JDBC drivers. And you may need to provide a list of all the nodes in that connection string so it can send it to all the nodes in the cluster. Okay, so hopefully that answered your question. Back to what we've done here. So that was the approach for using SQL for a design approach. And we'll get into that a little bit more. Okay. Okay, so focusing on the logical and physical modeling design steps, you might do something like use this, the dbdiagram.io. It's a great tool, and it allows you to do a lot of stuff for free without the enterprise or paying for it. So you can model visually, you know, what your database looks like. You can add columns, you can add relationships, you can add indexes, and so forth. It will allow you to export the DDL. You will have to adjust this for Ignite, because Ignite isn't one of the export engine types. You might want to change the index names. You should probably remove the foreign keys. You don't have to, but it's going to fail because it'll say foreign key is not, adding a foreign key is not supported. So that's good. Then on the physical side, you're going to want to look at so we've gone from relational and just designing it right and getting the table and indexes in here, which is partly physical. But from an Ignite perspective, some of the additional things you need to look at is thinking about your partitioning strategy and setting high availability settings, like back up your partitions more than, so you have a backup partition count of 1 or higher. You might want to evaluate your affinity keys, and you want to plan for your object model classes as well. So this might be something that you do where you, in addition to your adjusted DDLs, you might want to add this with clause here so that you specify. I like to name my caches a certain way. I like to have a backup of 1, so I've got high availability turned on. This particular table is going to be partitioned. I've got an affinity key around the employee ID. I've said the key type is an integer, and I've gotten myself prepared, if I want to, for object model classes, to set the employee class if I want to be able to extend SQL-based approach and take advantage of Java-based object models as well. Okay, so moving on to the second approach, we talked about the SQL DDL approach for design. Now, from a quote-unquote design of using Ignite examples, there's an extensive library that comes with Ignite and GridGain. Okay, so we're going to follow a somewhat similar approach, look at our requirements, map out the development cycle, what strategies do I want, what's the scope of your planned database system, However, from a design perspective, you're going to look at existing patterns, go through those examples and pick one that quote unquote matches. And then you're going to move on to implementation. You're going to clone and own. That's a better way of saying copy and paste. But essentially, once you clone it out of the Ignite repository, remember, you own it, and you're going to start making changes to it and extending it. Then again, you're going to load the data and run it and see if everything works, and you confirm it, etc. Okay, so what does that look like from a practical perspective? Okay, so when you look at the Ignite examples folder, you'll see a whole bunch of folders in here. And if you look at the source folder and browse through that area, you might see things like, oh, look at the binary object model. Hey, the compute grid. For today, we're talking about databases. How about the data grid? Oh, there's something here for a star schema. That's an interesting idea, because that's something I would need to do for analytics. The star schema is your go-to dimensional way of dealing with things. So there's an example for that. Let me pull that up, and I see, it's got a description here. It's using a snowflake schema. Really nice. So that looks like an example I might want to take. I'm going to copy this into a new project folder, and then I'm going to do some work. So there's a little bit of hand waving here, because I'm going to drag this over in here. It's going to land in here. I'm going to have to start doing some additional things to make this into a true Java project, but it's a little bit of busy work. And if you're a reasonable developer, you can copy in some of the other stuff. So for instance, when I bring it in here, I'm going to pick my own object model. I've chosen GridGain because I work for GridGain, and when I put it into my training example package, I might have to rename the package. My IDE helps me out. I've got some other things I need to copy in. I'm going to adjust that. I'm going to create a POM file, because that's what I like to use for making sure I bring in all my packages and stuff like that. I'm going to rename the artifact. I'm going to give it a version, and all of my dependencies are going to be in here. And then I'm going to build it. I'm going to clean and install, or clean and compile, etc. And if everything is successful, you have a build, and everything's good. You have a target folder here. Okay. All right. So we've talked about SQL DDL as a design, quote unquote, design approach. We've talked about using a Java-based set of examples that Ignite comes with, and copying and pasting, or cloning and owning. Isn't that a better thing? Clone and own, I like that. I think that was Microsoft. They cloned Sybase 4.92, if I'm not mistaken, and then ever since that, they owned it. And then Sybase, have you heard from them recently? No. Okay, so the third approach is to use the web console, and coming soon, the control center, to give you a web-based wizard to walk you through creating a cluster configuration from scratch, or importing from a database. In either case, you're going to get a Maven project that's patterned for building a good clustered solution that's extensible and a good way of doing things for the future. Okay, so the 4-panel advanced, let's see here, the advanced tab helps see capabilities that are available and builds up the cluster config. So for the cluster, right, this is the general settings for the cluster. It's not related to any particular cache or table. It's the general stuff about the cluster. Atomicity, general atomicity, discovery, communication, client things, et cetera, et cetera. Okay, here we're showing things like events, general events about the cluster, and the ability to set different values. And notice, oh, there's some things I didn't know about. So the fact that the panel shows you other related features is great, because it can help you understand what other features might be there, because there's a ton of features. And if you just sort of build from the basics from a particular example, you might not know other things are available to you. Okay, so moving on to the SQL scheme, this is where you create your table, your tabular structure of your IMDB. Okay, here we're going to add fields and indexes. Moving on to caches, that's pretty self-explanatory, but there are things under caches that are probably, okay, so here, for instance, I've opened up the general panel and I've set the backups count equal to 1. So every partition in memory has a backup partition on another node so that you get your high availability. You can also set the partitioning mode, atomicity, etc. There's also a section on the cache panel or cache tab that I think is kind of more related to SQL, but I'm going to highlight this for you. The queries and indexing tab is an important one for an in-memory database, because this is where you can set the SQL schema. Because if you don't set the schema, it's going to be in the public schema, and I think you want to have this so that all of your different databases have the proper schema. You can also set the history size, parallelism if you want to have more performance delivered to your SQL engine, etc. Now, again, we're talking about an in-memory database. Okay, this is on the cache store panel. You see a whole bunch of things about the store factory, and the default when we're importing or even creating a cluster from scratch is to have a store factory for JDBC POJO. Now, this implies that you're going to synchronize with a third-party persistence. So again, in the IMDB scenario, if you're not synchronizing with the database, but you're just loading or ETLing in, then this doesn't apply. So we're going to set this to be not set, quote unquote, not set. Okay, so we're going to change that to not set so that we're not synchronizing with a third-party persistent store, because we're going to use Ignite persistence. Okay, and then the final panel here, or final tab, is the GridGain tab. And on the GridGain tab, you can enable some features and turn on some of the enterprise features like rolling upgrades, so you can roll upgrades through your various cluster nodes, turn on security, etc. Okay, I got a question. Can you elaborate on how to run MLDL in memory? Okay, so backing up a little bit. So you've got an in-memory database or an in-memory data grid, either are fine. The ML and DL is let me bring it up. Well, hard time to bring it up. Let me just talk to it. But we talked about how, as consumers of a database, you've got the ability to run queries, run NoSQL, run ML, DL algorithms. So the DL algorithms like the naive Bayes or the SVM support vector machines or TensorFlow, these are all things that need to take advantage of data. Okay, so if you were imagining this with Python, you'd use something like scikit, and Python would create a data frame for the data and then pass the data frame to the ML algorithm. Similarly here, with our implementation of the algorithms, with the Ignite implementation of the algorithms, instead of creating a data frame, it knows that there's a cache. And more than that, it knows that that cache is a distributed cache. And so when it runs it, it knows to be partition aware, so that the algorithm, instead of having the cluster send all the data up to the algorithm, which will then run out of memory when you're in 2 terabytes of data and you're doing a longitudinal study, instead it's going to say, let me take that algorithm and let me send the first step out to the 100 nodes I've got. They do that first step, maybe the algorithm needs a second step. Okay, then once we've got to the second step, we run a second step. Again, we send the compute out to the individual nodes. So the idea with ML and DL is that we have Ignite-specific implementations of 18 or 20 of the most common ML/DL algorithms. They're implemented specifically for Ignite backends. So when they run on an Ignite cluster, they will take advantage of the cache and the distributed nature of the cache and execute in a distributed fashion. Whether those are then fully in memory or whether they are using Ignite and the cache happens to be using persistence, it will. So there isn't really a difference between in memory or not in memory. With Ignite, even if you are overflowing memory onto disk with Ignite persistence, it will load it and support the ML algorithm. Okay, so hopefully that answered that question about execution with ML/DL. Okay, back here to using our third approach, using the wizards to create our cluster configuration. So we've walked through the 4-step advanced panel to create from scratch the cluster, the tables, the caches, and any enterprise features we want. Okay. I think I've already done this. Okay. All right, so similarly, if we're using the configuration wizard, but the second one here, the import from database, then we're going to step through the import panels. Now, the import panels have 4 steps as well. First, we're going to select the database driver that will provide us with the navigation and introspection to the backend source system. Here, I'm going to change this to MySQL, and I'm going to give it a URL, a user ID and password. I'm going to choose the schemas within the MySQL or the DB2 or the SQL Server database that I'm going to look through. I'm going to pick that particular schema, and I'm going to move on to tables, and I'm going to select the tables that are of interest. I'm also going to specify the action that I want. You notice here that I've now changed customers, employees, offices to be replicated. Now, for those of you who've talked to me before, you know I harp on this, or not harp. I like this, to talk about this. I look at 3 core types of data. Reference data. You get reference data from the web. You get it from partners that give you reference data that doesn't change very often. You know, the list of colors, the types of cars, the customer segments that you have. That's master data, that's reference data. Then you've got master data that you as an enterprise own and change. But again, it tends to be smaller amounts. How many customers do you have? Yes, you could have 1 million customers. But if you got 1 million customers, you probably have 1 billion orders, hopefully, or hundreds of millions of orders. So in the scale of things, customers, products, facilities, these are master entries that are smaller in scale and can fit in a single node. And by the way, master data and reference data is joined to a lot for looking up information. Oh, well, what's the address of the customer? Oh, well, what's the, what segment is that customer in? So there's a lot of joins to reference and master data. So I use those as replicated, so they're available on every node, so I don't have to worry about the join to master or reference data. It's always available on every node. Colocation is built in because it's replicated. Larger tables, like your transactional tables, like in this case, orders and order details, those things are your big hitters. Those are your big ones. And those are, we're going to use the power of the cluster to expand and scale out as those gets into the hundreds of millions and billions of rows of data. For those, you see, you'll also want to, in addition to making a partition, you'll want to make sure that you've got colocation built in. Well, sometimes that can be a little tricky to configure if you're doing that in code, but it's very easy out of the box with the import wizard, because you can just, hey, for the order details, instead of partitioning by the natural key, partition it only based on the order number because now I know order number in details and order number in orders are the same. Therefore, the affinity of those two is exactly the same. That every order detail is going to be on the same node as its corresponding order. So the join from order to order details is always going to be on the same node. You're guaranteed that. Okay, I've harped on that. That was harping. Okay, let's move on here. Okay, then at the very end, you supply some options to this. The big one for me is the packaging. I like to organize my object model into nice namespace. So I use the company that I work for and the subject area. So com GridGain sales, com GridGain HR, com GridGain training, in this case, model, right? So all of my order details, customer, and all that kind of stuff are going to go into that package, so it's nicely organized for us here. Okay, so we've done all that. Once we complete the save or hit save on the import wizard, we're going to find it over here by going to our configuration tab. We'll see it starts off with imported cluster as a generic term. We're going to go into that and we're going to customize it for our purposes. So for instance, I'm going to give it a name, training import DB, for this cluster to keep track of it, because I've done lots of these and I want to have it different from the finance cluster that I built yesterday. I might want to go into the SQL scheme, and recognizing that I imported data from Oracle operational system that had my order data. Well, the operational system might have different indexes than what I want in my IMDB for analytics. So I might want to, for instance, add indexes to that, add a new index, in addition to what came out of the box and imported from the Oracle transaction system. Once I'm done, I can save and download. I get my little green everything saved, and it pulls down a zip file for me, and I'm good to go. And that's what it would look like. Now, whether we did I'm going to repeat that last 3 steps one more time. Whether I do a cluster from scratch, or whether I do a database import, which essentially gives me a cluster based on a pattern of a database, we need to take the design artifacts and deliver it to our development environment. Okay, so again, we select our cluster. If it was an import, we've already seen that. But here, if we're starting from scratch, we pick it. We download it from the action menu. Again, we get the zip download. We get our Maven project here when we open up that zip. We're going to go to our development environment. Here I've got Visual Studio Code. You could use IntelliJ or Eclipse. You drag and drop that into your development environment, into a nice empty folder there, and boom, it shows everything that you've got there. And it recognizes my POM file, sees it's a Maven project, and it starts to build it right out of the box right away as soon as we drop it in. So it's very productive. Okay, so that's taken from design and moving to development. Okay, so then how do we do development? So we've chosen patterns. We've created a SQL database by doing a design approach and getting the DDL it gave us. We took a Java Ignite example, and we copied and pasted it and filled it out, but we haven't done much with it yet. Or we followed the third pattern, which is using a wizard to create a Maven package based on the design that we've given it from scratch, or we've patterned based on a database we're mirroring or synchronizing with. How do we do our development? Okay, so we've got many approaches. Let's look at one. Okay. So let's first start with a reminder of GridGain at Ignite. Reminder to you that this runs anywhere. It runs on bare metal. It runs in containers like Docker. It runs in virtual machines, VMware, Hyper-V, etc. It runs on the cloud or on-prem, and it can be Kubernetes enabled as well. You develop with Java, C++, .NET, C#, for Ignite servers. You can use it with, what's the difference between developing and using with? I'll maybe try and explain that. You can use it with general tools for using SQL and JDBC and ODBC. You can use RESTful HTTP, Python, Node.js, PHP, Java, Scala, .NET, C#, C++, etc. The using, what I mean by using is essentially creating solutions, the part of the solution that is consuming, not the data servers, not the compute servers. That's to do full-scale development. You need to use one of these three. You can also use Kotlin or Scala, because those are essentially Java compatible as well if you're interested. We don't have a lot of documentation on those. But in any of these languages, you can build thick and thin clients based on which language. Some languages like Node.js and PHP only support thin clients. Python by default supports only thin client, but there is a open source option to use a thick client version of the library that's been implemented as well. Okay, so let's get into the development tools for each of those three different environments. Okay, once the cluster config is designed, either from scratch or from the import data wizard, you need to take the design artifacts and deliver to the development environment. Okay, I think this is the wrong thing. So from a SQL development tools perspective, included out of the box or with the installation, there is a tool called SQL Line. It's in the bin SQL Line, SQLline.bat or .sh folder. And if you if you look in here, you basically start it with SQL Line. You give it a URL. You connect to JDBC, Ignite, Thin, localhost, URL, and then you're in. At that point, you can do things like there's some commands like question mark tables, or you can also just run SQL in there. DDL, SQL, all the things that you might want. You can just do question mark help or bang help if you want more help for what's available there. Personally, I like dbeaver, but you can use any JDBC tool that you might want to use here. dbeaver is great because it visually shows, once you create an Ignite connection, it will navigate and browse through the metadata that you've got in your cluster and show you the schemas, the tables columns, the unique keys, what indexes. So here we see that the customer type index is an index, ascending index based on customer type. And looking at the data, we see that there's a sequence number, a UUID, blah, 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 blah. So it's just a great tool that you can use out of the box, and I can run my queries, DDL, alter tables, anything through this tool as well. However, for those of you who might want to use your cluster with Python as an example, you might want to use Jupyter Notebooks or Jupyter Labs. Here's an example where we, create the some DDL, we connect to it and execute our DDL, and we can create a table straight from Python or PHP, etc. So you can use virtually any tool to do SQL development. You could even use Java Ignite API tool. There's lots of examples that just have the create table right in the Java code. You basically just say SQL execute this string, and you can do it there. But I like my middle option with dbeaver if I'm doing database-centric development. Okay, Java development tools. All right, so what are the approaches for Java development tools for Ignite? Well, you can just use Maven right out of the box. That's what we deliver. We give you lots of POM files that you can use out of the box. And all you need to do really is, I think I've got it there, do the Maven install against a project, for instance, the project you've downloaded from your the wizards, or the example folder can be built as well. You probably don't want to do this first on a project that you're building, because you probably want to edit your dependencies, go into your POM file, figure out, what version do you want to use of Ignite. Here I'm using the GridGain version, but if you want to use Ignite, you can use 2.9.0 or 2.8.1, etc. Okay, what libraries do you want to include? Do you want to include a RESTful HTTP? Here I've added MySQL JDBC driver because I did it with a database import. So you want to edit your dependencies in a POM file. Here again, I don't even use an editor. Well, I guess it's an editor, it's just Vim or VI. You might want to use a deployment descriptor like a properties file. Because I was using MySQL as a database import, we out of the box build a properties file for you and put it in here. And then the configuration that we build for you uses these properties in your project, so you can know that you can deliver this to your DevOps team, and they can just change the deployment scripter and do this here for dev, change the URL or the password for production, and it's a nice patterned approach for delivering your solution. Okay, probably you want to use, if you're going to be doing this in Java, you're probably going to be wanting to use an IDE. So I like VS Code. I used to be an Eclipse guy. Now I'm all in on VS Code because I think it's lighter weight, and I think it's just a fantastic environment. And I like command line, which you can do in here as well. I like to run it in Unix or Linux. All right, so VS Code, as you see here, when I drag and drop the wizard in here, it just opens it up. It expands the Maven dependencies and gives me the ability to, well, I guess I can show that a little bit later, and then you can build it straight from here. If you want to use Eclipse, again, you can import from a project from an existing Maven POM file, and it's going to build something very similar. It's going to give you the source. It's going to see what resources. It's also going to give you your Maven dependencies by looking in the POM file and allow you to, again, edit your POM, edit your properties file, and it also look at some of your Java code, your DOM stuff as well, or object model. Okay, and if you're building in Eclipse, you can just click on the POM file, right click and say, hey, I want to do a clean install, and you're good to go. Now, I don't use IntelliJ. I didn't have time to get my environment set up and running, but it would look something like this. And again, you can run a Maven build and do the exact same thing you can do with Eclipse. Okay.
Hey, Glenn, there's a question there about the difference between thick and thin clients. What are the differences?
Okay. So a server is thick. I know you didn't ask that question, but a server is thick. Thick in the sense that it joins the topology and it has full visibility to all of the nodes that exist in the cluster. So if you have 100 nodes in your cluster, the thick servers know about them all and participate in transactions and the distribution of the data and the execution of compute. Okay, so you asked about clients. Well, if you take everything I just said about servers, thick servers, and think thick clients, the only thing that's different is that thick clients don't store data. There's a little bit of a proviso there because there's something called a near cache. But let's ignore that for the time being. Thick clients participate in the cluster. They know where everything exists, so they can ask directly the right node for the right piece of data. Their main job is to perform compute. So computes are best done on client nodes. Well, not best, but they help because they can separate a data node that is just strictly going to handle all the data tasks from a compute node that can sit off it and then scale to meet the compute needs. So you can scale your data, scale your compute, and keep them separate. That's a full thick client. So it knows the topology of your data. So it's partition aware, it's data aware, it knows where to ask for the right data. It runs it has a full API support, except it doesn't store any data. Okay, a thin client, on the other hand, does not participate. By the way, let me say one last thing. Any node that is thick client or thick server is somewhat expensive. What do I mean by that? There is a task for everyone in the cluster to be made aware of Johnny or Sally joining the party. When Johnny or Sally join the cluster as new nodes, we need to know about them. They're in an order in the ring. We then might distribute data over to Sally so Sally can hold some of the data. And we now know that Sally has data, and we've replicated the data to Sally. While we're doing all of this work in the topology and distributing of the data, that can be very expensive because we're not allowed to make transactions or execute transactions. So things have to be quiesced while topology changes occur. Okay, so thick clients, though they don't share data, they are still somewhat expensive because they still have to be made aware of. There is a stoppage as they join the cluster, not as bad as distributing data to it, but they are still somewhat expensive. Thin clients, however, do not join the topology. The server nodes don't know about it. The servers don't tell it when, hey, I just deleted these 7 orders. I don't tell the thin clients about that. I do tell every other node, including client nodes. Client nodes know when things happen about all the data elements and service compute elements. Thin clients are not participating in transactions. They're not participating in the distribution of the data. And so they're extremely fast to connect, but they're not participating in any transactions. And so if you were to do something with the data, do a query, for instance, after you do your query, the fact that I've deleted some of your orders, you won't know about it unless you requery. Whereas a thick client can be made aware of that and know about that. So a thick client is kind of feature rich, but it's bigger, hence thick. Thin doesn't have as many features, but it's much faster. So if you're gonna be doing things with coming and going a lot, have it be a thin client. If you're gonna be sitting around for a while and do stuff, like with computes and services, have it be a thick client. Hopefully that answers that question.
And very quickly, the next question is there any Golang support for Ignite APIs planned?
I don't. Actually, you know what? I did hear yesterday one of my compatriots working on a Go project. So I believe there is some work being done, but I don't have the details. So you're going to have to look. Maybe ask that in the Ignite Apache Ignite user community. They should have an answer for that.
Yeah, Anthony will follow up with you. Sounds good.
Okay. So where was I before I got distracted, before I went into a tangent of long discourse? Deployment. Okay, so we have many deployment options and monitoring facilities because you saw Dennis's lab. Okay, so how do you get from development to deployment? What are the steps there? Well, it depends on your environment. So if you are deploying to a runtime that is your development tool, does that make sense? Deploying to a development runtime. Well, I think it's important to think about that scenario because essentially deployment is making it available for runtime. And so you're going to run this probably many times, probably more frequently as developers. You're going to run it more frequently in development. You're going to iterate and run and run and run and run and keep running. It's important in this environment to understand that if you're going to, for instance, here, let's start our server node with the pre-built wizard-based tool that would come with it for starting your node, starting your server node using Spring config? Well, it's got a little main here, and VS Code has nicely highlighted that you can run it directly. So I click on that. It's important to know when I do that run that it's going to use the libraries that you specified in the POM environment that your Java development IDE knows about. It doesn't know that you've installed Ignite. It doesn't know that you've installed GridGain. It doesn't know any of that stuff. It only is deploying the classes into its local environment, and it's running those classes that you've compiled and built yourself, and any libraries you've told it about. So if you've built for Ignite, or what did I do? I built for GridGain 8.7.29. I'm not running this in the installed Ignite 2.9.0. I'm running it directly from my development environment and the class path that it's building. So essentially, deployment to a development runtime is essentially when you do a build and compile, it's there, plus all the libraries that you manually or automatically through Maven imported into your IDE or your development environment. So that's important to keep in mind, because that could be vastly different than what you have in your application runtime where you've installed Ignite or GridGain. Okay. So now deploying to run this in an actual installation. So in my IDE, when I do the compile or the install, notice that I get built a jar file, because when I do my Maven build or compile and install, I get this building jar, and I have this jar, and this is where it exists. So what do I do to get this into my Ignite installation? Well, I drag this file from here onto my Explorer, or I copy and paste, or I go onto a, however I get that file. You guys know how to do that. You're gonna drag it into your Ignite libs folder, and then start with ignite.sh. Everything in this Ignite folder, except optional, so everything in this folder at the base or the root of the folder, and all subdirectories, all jars in all subdirectories all the way down, are brought into the class path of your runtime when you install Ignite and you use the Ignite scripts, ignite.sh, ignite.bat. So you need to move your built jar. To deploy it, you need to move it into your runtime. Here I'm dragging and dropping the jar file over here. So if I'm doing this from Ignite or GridGain 8.7.9, and I'm dropping this into 8.7.28, as I see here, keep in mind, I built for, well, actually, in this case, I built for 8.7.9. You built for 8.7.9, you're dragging it into 8.7.28. Those are compatible, so forward compatibility is fine at that level, but just keep in mind, I picked the control utility. I've got Ultimate, I've got Control Center Agent, I've got Spring, I've got REST, I've got Open Census. If I need something that I put in my development environment and it's not here, it's not going to work. So if I was relying on Log4j2, I don't have it here. I haven't installed that. So just got to keep that in mind. Deployment is moving it over, but your IDE libraries and your libraries here are done completely different. You've got to keep those not in sync, but in mind. Okay, so if you're deploying for running into Docker or Kubernetes, out of the box, we give you a Docker file, and in here, I would make your change into, actually this is wrong, this is not gonna work. GridGain Pro, it's actually not called GridGain Pro anymore. So the wizard is a little bit old. You wanna get the latest and greatest, and I think it's GridGain Ultimate or GridGain Enterprise or GridGain CE for Community Edition, or Ignite. You can get those from here. And then it'll import everything that you've just done here, and now this will run inside your container in Docker, and then you can deliver it to Kubernetes as well. Okay, so I've gone through the design through deployment approach for building an in-memory database using 3 different approaches. DDL-based, design the database, create the DDL. Java Ignite examples, customize it, clone and own. Or the wizard, take the pattern that we give you, extend it, and customize it. I personally like that last one because I think it builds a nice organized Java environment for you. But if you're focused strictly on databases and you don't care about the object model, you're not going to be doing events, you're not going to be doing computes, you're not going to be building services, then the first one is great as well. I think the examples, I don't think they're great for building patterns for scaling up to production. I think they're great standalone options for showing you how to do things well. But is that well with everything else you're doing? That's up to you to take that kernel of truth and build it for your broader runtime environment. Is there a question? Because I got something flashing, but I can't necessarily see.
Yeah, so there are a couple of questions. One is a time check. I think we have another half an hour, right, Glenn? And then we'll have and then we'll, audience will have like a half an hour break before our next session starts. So if you're planning your breaks, that's the plan. And then one question was around data ingestion, the concept. It was like, which one would you recommend for data ingestion, Ignite Data Streamer or Apache Spark, and why?
Okay, well, that's a great question. I thought you were going to just give me an easy question, but no, you threw a curveball in there with that. Okay, so we have a interesting relationship with Spark. Spark, as you know, is a distributed compute, but it doesn't have data, right? So you have to always do stuff to either have the CSV or ORC or Parquet files, and it has challenges there with multi-step execution, et cetera, et cetera. But if you're using Spark, if you like Spark, if you're comfortable with it, our Spark save option, so when you do a data frame that is targeted as an Ignite cache, the data frame save is stream enabled. So just like SQL inserts can be stream enabled, Data Streamer is obviously a streaming tool. Our Spark data streamer, or our Spark data frame, when you do a save, is streaming as well. So you get the performance advantages there. You have, if you are a Spark user, you get the advantages of tying in with any existing Spark pipeline you may have built. And so I would say to you the following: if you like Spark and you're using it already in your data pipeline, then use the Spark Ignite integration, create a Ignite-based Spark data frame, and hit save. And you're going to get great performance out of that. If you're not familiar with Spark, and if you haven't built Ignite pipelines or Spark pipelines already, you may be doing double dipping a little bit on the technology, and so your stack is a little bit big. And so I wouldn't suggest you do it unless you have a reason to do it. Hopefully that answered your question.
Yeah, Glenn, it looks like we're kind of, probably should continue. We have a few more questions, audience, and if you don't get to it live, we'll certainly get back to you later after the event.
Okay. Let me get out of my present PowerPoint and open up. Okay. So I just want to reinforce again, this will be coming to this will be coming to the control center, but it's scheduled for end of the year. So in your web console, if you're doing actually SQL DDL, sorry, I'm using the wrong order. Okay, so in here, if you are building a application through a database development tool, I like dbeaver. There is an easy ability to create a new connection based on Ignite, and it's very quick. You almost don't have to fill anything in localhost. I'm going to pick training as a database and finish. That's very easy to do. That'll give you access to your running Ignite cluster. I like to, if I'm doing data-centric approaches, I like to organize things in a folder. So I create a training folder. I've got my connection in here, and I have my scripts in here. And again, you might want to browse through what you already have. There already is a train schema. There is a public schema, a big schema, etc. But you want to see what you have already and then maybe do some development. If you are wanting to build new, whoops, everything seems to be deleting from my, as we look here, it's deleting all my files. What happened? Let me refresh this. I may have moved things. Refresh. Oh, they showed up. Oh, there we go. Okay, so I did move my folders around. So here we go. So if we were building the employee table, for instance. Okay, this is for loading data. If I was building the employee training database, notice while I'm a little frozen here, because this is actually a 2 million row file, or 1 million row file. It's a little big. I want to highlight something. So for streaming, we do support set streaming on. You can insert into. Notice every insert can be a batch of 10, or I picked 10 rows here, and then it goes on and on and on. I'm sorry about that. Let's maybe move on, because they have okay, good. Got out of there. Okay, so in here you can do essentially what you would want to do: create tables on the fly, etc. Execute what you want, insert individual records, all that kind of good stuff. I highly want you to. I want to focus strongly this section of code here, where the with clauses that are not ANSI 99 but are passed through to the Ignite database engine, things that are essentially below the tabular world. These are essentially cache-based things, and these things set your name of the cache, backups, partition to replicated, infinity key, etc., etc. You can also create indexes, alter tables, drop, etc. You can use the if not exists, etc. So this is essentially how you can work with your existing database and do stuff on the fly, change these things. You can build, I think I lost my connections. Yeah, I lost my connections. You can create DDL from existing tables you've got in Ignite. So it's a very productive environment here to work with. The other important thing to keep in mind here is that in your driver, there are a ton of properties. So if you wanted to, for instance, take advantage of partition awareness, as I mentioned before, that's a new feature that was added. So that's somewhere we can get some advantage. Even though it's a thin driver, you can take advantage of it there. Okay, so let's move on. So there's nothing really unique here in building SQL from DDL. You just make sure you have either your SQL or your SQL line. And again, there's lots of things here tell you what you want to do, execute queries, turn off various features, etc., etc. Right? So that's good. All right, so if you're building a new, let's build a new configuration from scratch. Now, I could import from database or create a cluster. It doesn't really matter. I like importing from a database because then that means I don't have to create. Sorry, a little construction going on here. Importing from a database and picking my tables. I like MariaDB. Hopefully I got that right. Pick the schema that we want. Maybe I want all of these, and maybe I want the value, all of these to be replicated because these are smaller size and I want them available on every thing. Entity attribute, that's also replicated. And then value is going to be partitioned. Okay, so that's what I would do there. This is going to be my training package. I'm going to hit save. And I will now have a new imported cluster. And this is very useful. Imported cluster, there it is. I go into that. And I'm going to call this EAV, the Entity Attribute Value Schema, which is a neat data model for those of you looking for extensible data models very easily. All right, so in SQL, always hit save after you do something in any of the panels. When you save it, you should get your save and then move on. So if you're going to change something, yes, you're going to turn on the HTTP REST. Yes, always hit save and go. So on to SQL Scheme. We have our various fields here, or sorry, tables here. We've got 4 of them. And for this table, since it saw what it saw, it sees that the key field is the name. You might want to create a new index against the data type, for instance, or the description. I might want to say, hey, I want to create a full text index on the entity description, full text. And oops, I think that was incomplete. I need to specify what field to use. I'm going to use that description field so I can search for that and save. All right, always make your save changes. Once you're happy with your changes to your tables, you move on to caches. Caches, things like your memory. Are you using on-heap memory? Are you, some of these things like the indexing, this, I'm going to put this in a particular schema. I'm going to change that to the EAV schema. And I'm going to turn on history so I can watch this and have a history of my things. I'm going to save, I'm going to change my store, and I'm going to model it, but not synchronize it. So I'm not going to use this, and save. And then cache, so that's it. And I'm not going to turn on any GridGain features. So I'm basically done. I've got my new cluster called EAV. Let's call this training EAV because I may have one of those already. Train EAV, save. And now in here, when I look for training, there it is. I can select that and download the project. Open that up. And we have our project. Okay, and we will go over to training. I'm going to create a new, call a new one. drag that in. And open this up in my IDE. You'll see it start looking at the fact, recognizing this is the Java Maven POM project. It's building these things. It's going to build our Maven project. It sees what it is. I might want to change this, as I said. So while it's doing that, I'm going to change this. I'm going to change this to software might be 8.7 whatever, but my project is 0.0.1, and I'm going to change this from 8.7.9 to the version that just came out yesterday, 8.7.29. Ignore. Sorry. Replace all of those things there. And then if I want to add more dependencies, I can, but let me hit save. And you should see in here that the Java dependencies are changing. And it's going to download. It may need to refresh the project. Once I'm happy with that, I can install this. It's going to essentially do a Maven install on that POM file. It's going to build the project. It's going to download everything, and I made a mistake. I don't have my MySQL connector. I really should have used this MySQL is wrong. I'm going to remove that from my project because even though I use MySQL to pull it in, I'm not going to use it for my application. So it saves. I'm going to remove it. I'm going to rerun the project. Install. Build my classes. And since I pulled out MySQL, it didn't work. But that's essentially the process that you would follow for building a project from a cluster configuration that you've used either via import or through the web console config wizard. For the exercise, or for the examples, you will see in any installation, Community Edition, or any of the many versions of Ultimate or the Ignite version. I do have Ignite, the open source version. Ignite, got a link to the latest version and examples. Go to the source name, Java, org, Apache, Ignite, samples, and here's where you would want to maybe pull a particular thing like the star schema, or maybe any individual one of these things, or you can pull in the whole example folder as a project into IntelliJ or Eclipse, and this will give you access to essentially all of the values, and it'll build the entire Maven multi-project structure for you. It might take a while to import all these things. I don't really have much else to show you at this point, so we can use the next 13 minutes to answer questions, Venkat.
All right, that's great. Thanks, Glenn. So, I mean, one of the questions, some of these questions came early in the presentation, so we may want to go back and forth, but one of the latest ones I had is about affinity. If you have key value pair data, how do I make sure that the data is together in one node by a partial key?
Okay. Yeah, it's a great question. So let me pull up dbeaver here. Okay, so okay, so I've got two tables here: contact, which is the contacts for a particular customer. So I'm going to open up these two tables. I think those, make sure that those. Let me shut down this one. Make sure just my the right cluster is available. Okay, so I'm going to open up customer and contact, and these have I'm not sure, but all of a sudden my cluster is broken. Let me just shut down a few other things here. Let me. Let's. I'm not sure why my queries are running. It's a very big database, and it might be running out of memory. But so let's look at my two tables here. So I have customer, which has a sequence number, a UUID for the customer, and then name, description, etc. And then the contacts has the same sequence number, and then name of the contact. And this is a contact name. So there could be, you know, I might have a customer number, but my wife has one contact name. I have one contact name. So the same customer can be with multiple contacts. So the point here is that the index on the contact is state and, sorry, the unique key is, well, it doesn't show it here, but it's multiple columns. So you need to, when you specify the DDL for this, you need to make sure that if this has two columns and this has one column, the default is to use the key for the cache. And if the cache has or for the table, the table has two keys, it's going to use both of those. So when it figures out where the data should land, it's going to take both keys, it's going to do some hashing of those two things, and it's going to come up with a key ID field, affinity key. That affinity key will be stable, so anyone asks the question, customer 123 contact Glenn, where does that go? That's on node 3. Customer 124 contact, or so anyone asks that question, we'll know exactly what node it goes to. Same with customer. So customer keyed by sequence number or the UUID, whatever the key is. If it's got a single field, it's going to use a hash on that single field and go to that node. So if you say to a multi-key table, don't use both keys, just use the key that this guy was using, then the hashing algorithm uses sequence number or UUID or whatever it is. It's the same number. And so since they're both doing a hash on the exact same number, then the contact will go to the same node, node 3. Customer, node 3. So because they're using the same fields for the affinity, the key is calculated at the exact same value and it's going to go to the same node. You can do that by, in DDL, specifying that even though the employee address in this case is keyed by employee ID and place name, this is keyed by employee ID, the affinity key is going to be just the employee ID. So by specifying the affinity key to be the same as the affinity key up here, I didn't have to specify it because it would be the default of the primary key. But by making these affinity keys equal, the hash on the employee ID will be the same. And so even though this is the address, because it's the address for employee 123, it'll be on the same node as employee 123. So in the SQL DDL, you specify that by specifying the affinity key in the with clause. If you're doing it in Java, the code looks slightly different. It will be in the config, you will specify an affinity key in here. I'm not sure exactly where it is, but yeah, it would be specified in here if I had done it. It would show up in here. So that's how you specify the affinity to make sure they're in the same place.
All right. Here is a sort of a fundamental, like foundational concept question. What is the difference between using Ignite as an in-memory database versus using it as a cache?
So an in-memory database, remember, think of it that the cache is not responsible. It's juvenile, it's young, it's not 18 yet. You know, if he does something wrong, if he commits murder, whatever, you start fresh, everything's fine. A database is responsible. He's over 18, and you know what? He's got to take responsibility for his actions. So an in-memory database should have persistence. That's what we think of as persistence. So Ignite has Ignite native persistence. It's a durable storage that backends the memory of the in-memory database. And by the way, once you do that, backend it with database with files. You also have a transaction log. You have scaling. You can expand beyond how much memory you have. And so an in-memory database is durable through restarts. It has transactional storage on disk that can recover over failures. A cache cannot recover from failure. A cache, when the cache goes down, that's all right. When you start back up, I have to reload. You have to reload the cache. Now the cache can, slowly warm up and get reloaded on the fly. That's fine because it has read through, right? If I start up the cache and let's say I had 100 million rows in my cache, I close out, I restart the cache. When I ask for employee ID 123, it's not in memory yet. I read through, I get it from my Oracle system, the cache then loads it up, and it gets loaded automatically through cache read-throughs. And I can also warm it up by initiating a load of the cache if I don't want to have to wait for everything to load up slowly. So cache is volatile. If the cluster goes down and starts back up, the data is lost, and that's okay because we have the data somewhere else. For an in-memory database, you're responsible. You use Ignite native persistence. The disks will see you through cluster restarts, but still give you durability and still give you read through, write through. And Ignite native persistence has one advantage over caches and its read through capability. It has query through as well as read through. So read through is read, I've got an ID, I don't have it in memory, read through to the backend database. Query through says, hey, I don't have the ID, I'm running these predicates where shoe size is greater than this, customer type is this, city is this, go do the query. Some of that might be in memory, some might not be, and it might have to go to Ignite native, some of the partitions that are only on disk. That's the difference.
Awesome. Maybe a couple of questions before we end this. One was asking, can you talk about performance numbers for a 3-region cluster across regions, not just availability zones?
Okay, so we generally do not recommend clusters span regions. You can do it, and that's what we call a stretched cluster. So again, the default in multi-regions, New York, Virginia, New York, California, New York, London, etc. The default in that scenario is to use data center replication, but I recognize that that's a enterprise feature. But you could use Kafka, you could use other queuing tools to move the data between regions. That would be our default answer. If you're willing to live with some of the provisos that a stretched cluster, brings with it, then you can do a stretched cluster. The problem with stretched clusters are that because all nodes in a cluster are very talkative and they notify each other of changes in transactions, they hold things, they keep things bound tightly together, you need low latency and a lot of data transfer. If you're going to do that, and there are some cases where a stretched cluster, let's say you want to have a global unique order ID, so you maybe get the order ID from the stretched cluster, and then from onward, you now will use a local cluster for all of the activity on that node, and then distribute the order once it's done. That's a great pattern. Some in the stretched cluster where you need globally unique, globally consistent data, use a stretched cluster for that, but don't use it for a lot of data. And then have a local cluster for your heavy data usage, and then use data movement, either through Kafka messaging, etc., or our data center replication, move the data in batch, in messages, changes from node region to region. So you should have, if you're going to do a stretch cluster, you need to have ultra low latency lines. I would suggest anywhere that you have fiber within it. So you could be within a 10-mile, 25-kilometer region and get that kind of low latency, high bandwidth in some, and get the kind of speed you want. But preference would be to stay within availability zones and within regions, not span regions. Different availability zones can be okay because those are more about isolating the nodes from failure. So we have a pattern within a single cluster for multiple availability zones where you can use user properties to say, what availability zone am I? Okay, then I'm going to have all my primary data on here, and if I'm on node 1 or on availability zone 1, back up the primary onto backup node in availability zone 2. That's a great pattern using node deployment user properties to decide where you deploy primary versus backup nodes. Hopefully that answers the question.
Awesome. And maybe just we are out of time, but maybe last question is, can I store SQL query output into another Ignite table?
Yes, there is an insert into based on a select.
All right. Thank you, Glenn. That
actually, I think it's select into. It's one of the two. I always forget one of the two. It's either select into or insert into with a select. There's Perfect. A DDL reference in the links that I gave you. There's a command reference for SQL in there, and I think it's either insert from a select, I think.
Very nice. Thanks for the presentation, Glenn.
Thanks, everyone.
Thanks, Glenn.
Have a great day.
Yep. Bye.